When shopping for neodymium magnets, you will meet a term called grade, which is typically shown as a capital N followed by a 2-digit number and maybe some extra letters. But what does grade mean? Well, the grade is a measurement for how strong the magnetic material used in the magnet is. I like to call it how concentrated the magnet is, because a magnet's total strength depends on much more factors than just the grade. But if you have two magnets with the same size and shape, where one is grade N45 and the other is N52, the grade N52 magnet will be the strongest since it is more concentrated. The N stands for neo, which is short for neodymium, and tells us that this is of course a magnet of the neodymium type. There are generally 4 types of magnets commercially available, but I will focus on neodymium magnets and compare them a little with the ferrite magnets, which are the most common. The number after the N stands for maximum energy product in megagauss-Ørsted. Sounds really complicated, and it actually is, but just think of it as the maximum strength of the magnetic material. Okay, so an N45 magnet is a neodymium magnet with an energy product of 45 megagauss-Ørsted. Not necessarily. Neomagnets are made of a crystalline structure that is impossible to make perfect every time in all of the magnet at an atomic level, so no two magnets are exactly the same. The industry has therefore accepted a range for each grade. The final energy product for an N45 magnet is between 43 to 45 megagauss-Ørsted. In the high-grade N52, where the limit of mass production seems to be at the moment, it is even harder to achieve perfection, especially in larger magnets. Therefore, the range is sometimes 49 to 52 or even 48 to 53. Check the seller's specifications. These ranges for each grade also makes it very hard to predict how much stronger a similar sized N52 magnet is over an N45 magnet. It isn't just 16%, but could be at least anything between 11 to 21%. In practice, it can be even lower. A practical rule of thumb is 1% more pull force for every extra megagauss-Ørsted. That is 7% more strength in an N52 over a similar sized and shaped N45 magnet. In fact, they are both very strong. Let me just compare their strength with the ferrite magnets that most people are familiar with from fridge magnets. Let's say that a ferrite magnet is equal to the strength of a beer. How strong is a neodymium magnet then? Well, it's more like vodka. You can get work done with ferrite magnets, like beer will get you drunk. You just need a lot bigger volume compared to neodymium magnets and vodka. By the way, do not drink while handling large neodymium magnets. They can crush you beyond repair, and they are always turned on. Just waiting for you to make a small mistake. Oh, my dear beer. Okay, let's just test all this theory with a real-life measurement. Using a small steel bracket and a fish weight scale, I will test how much pull force it takes before the magnet gives up. The ferrite magnet gave up before I really got started. Now I'll battle the neodymium magnet. Now that's what I call a magnet. Given that this was a crude ghetto-style test and the ferrite magnet used was 50% thicker, I think it's fair to conclude that as a rule of thumb, neodymium magnets are on average 10 times stronger than ferrite magnets. So the conservative rule of thumb for comparing neodymium grades can't be used when comparing neodymium and ferrite magnets. They are simply in different leagues. Finally, I will explain the extra letters that sometimes are at the end of the grading. These are codes for how well the magnet withstands high temperatures. The standard neodymium magnets with grades without letters after the number can generally withstand temperatures up to 80 degrees Celsius. If heated above this, they will lose some of their magnetic strength even after being cooled down again. My N38SH magnet can withstand up to 150 degrees Celsius. The disadvantages of these high temperature magnets are their lower strength and often higher price. To make a neodymium magnet more heat resistant, the perfect formula for the crystals, 2 atoms of neodymium, 14 atoms of iron and 1 atom of boron, is thinned out by other elements. For example, some of the neodymium can be replaced by dysprosium or praseodymium, and some of the iron can be replaced by cobalt. If you want to know more about size against grade, you should watch my video about it. You could also subscribe and like if you have watched this far. I have loads of ideas for upcoming videos about magnets and the beauty and fun of science. Thanks. See you later.